Here in this video, we're going to look at what's called the mean value theorem for integrals. And it says that we have a function that is continuous on the closed interval from a to b. It tells us there's going to exist a number c within that interval such that the following equation is true, where the integral of our function from a to b is equal to this f of c times b minus a. Before we explain this, let's look at the graph over here at the right. We've said before that when we were looking at calculating the area under a curve, we looked at using rectangles that were inscribed and circumscribed. So for example, if we looked at the inscribed rectangle here, it would go up to the bottom of our curve and go over and down. And clearly this area of this rectangle is not quite the exact area because it's a lot smaller because we're not including all of this extra area here that's under the curve. Well, we then said we could take our rectangle and circumscribe this, and we would end up with our rectangle that goes up and over. But now the area under the rectangle is greater than the actual area that's underneath our curve. What the mean value theorem here states, it says that in between a and b there exists an x value, and we're going to call that c. So there exists some c value within the interval from a to b, which if we go up to the graph at that point, which would give us this f of c, and when we see f of c here, that is really just the y value at that point. And if we were to form a rectangle here from a to b and using this f of c as thinking of that as being our height of the rectangle, and then down here, what's the width? The width of our rectangle would be b minus a. Then that area under the rectangle is going to be identical to the area that is underneath this curve. And you can see then what we're saying is essentially we could think of taking this piece that's under the curve. Notice that's above the rectangle, but we also have this equal space over here. So if we were to flip that down, that would give us the exact area that is underneath the curve to be equal to the exact area that falls underneath our rectangle. So if we go over here to the formula now, it says f of c. Well, we said f of c here. We could think of this as the height of our rectangle. Okay, so here's f of c. That's just our y value representing the height of our rectangle. And of course, then b minus a can be thought of as the width of the rectangle. So really, this mean value theorem is an existence type theorem. It says there exists this c value in which the area under the rectangle is equal to the area that is underneath this curve. Now, keep in mind, there could be more than one c value in which this exists. So let's look at this with the following example. We want to find the value or values of c that's guaranteed by the mean value theorem for integrals for the function over the interval from 1 to 3. So our interval here, we're going from 1 to 3. And if we're going to integrate this, then the integral would go from 1 to 3. And I'm going to make this 9x to the negative 3 dx. So if we integrate this, this is pretty straightforward. We would simply have 9x to the negative 2 divided by negative 2. And we would evaluate this from 1 to 3. And as always, I like to make my exponents positive, so we would end up with a negative. Take our negative here, I'm just going to write that in with the numerator. So we have a negative 9 over 2x to the positive second power. And again, we're going to evaluate this from 1 to 3. So starting with the upper limit, if we plug 3 in, you're going to get 9, so the 9's cancel, so you're left with a negative 1/2 minus, plugging in a 1, we're going to subtract away then a negative 9/2. So that's really negative 1/2 plus 9/2, which would be equal to 4. So that's the integral. If we go up to the theorem now, we said that the integral is equal to this f of c times b minus a. So I'm going to take our integral then here, and this is going to be equal to f of c times b minus a. So that means our integral was 4. That's going to be equal to f of c. Well, that's what we're trying to find. We're trying to find the f of c, the y value, and we're going to multiply that by b minus a, or 3 minus 1. So we would end up with 4 equals this f of c. 3 minus 1 is 2. So if we're solving, we would divide both sides by 2. So 4 divided by 2 is 2. So f of c is equal to 2. Now keep in mind that is our y value. So that says if we go over here and if we go up 2 places on the y-axis, this is our f of c. And we want to know then, what is the x value? Now, for example, we could go over, we want to find what is the x value. So what is the c value occurring? And if we take this, we can take and plug this, which is, again, f of c is just our y, and plug that into the original function. So we're going to plug that in as our y. F of c is the y, so y equals 2, so f of x is the y, so we're going to plug that in here for the f of x. So therefore, we would end up with 2 is equal to 9 over x cubed. Well, what goes in for the x? Well, that is the c value. Our c value here is the x. So we're going to plug c in for x. So we end up with c cubed. Because another way of thinking of this problem is this says f of c is equal to 2. That's like saying when our c value is x, our y value is 2. So we're plugging 2 in for y, trying to find what our x value is. So c goes in for x, 2 goes in for y, so then we solve for c. We have 2c cubed equals 9. So that means c cubed would be equal to 9 halves. Or we could actually then say that if we take the cube root, c is equal to the cube root of 9 halves, or approximately we'll just round this to about 1.7. So that is our c value. So up here, that says that we have a c value here that is approximately 1.7. So if we were to then draw the rectangle, then here at 1.7 is our c value, then we could see that our rectangle would start here at 1. We would go up 2, that's our f of c, and then over and down at 3. So the area underneath this rectangle then is the area that is underneath the curve. So that is our applying our mean value theorem to find this c, and we also found f of c. Now that leads into the definition of the following problem here, and it says that the average value of our function. Okay, now before I get into this, up here above, when we found this f of c, this f of c here is actually the average value. This is the average value of our function, the f of c here, which is really just the height of this rectangle. So down here, it says that if we're finding this average value of our function, this average value then is simply going to be 1 over b minus a times f of x dx. Well, where does that come from? If we go back up here and look at our mean value theorem, what if I was to solve this just like in the algebra equation, f of c times b minus a? What if I want to divide by b minus a on both sides? Well, then if I do that, the b minus a on the right cancels out. So we're left with this f of c is equal to 1 over b minus a times the integral of f of x dx. And if you notice, this is the average value, which is the f of c. So over here, f of c, we just found the average value. Now for our example, we said here the f of c was equal to 2. So this is the average value that we just found. Well, by rearranging the formula, we could easily find this because it said here this average value is simply the height of this rectangle. So here, 1 over b minus a times the integral of f of x dx from a to b. Well, if we look at the same integral quickly here, 1 to 3, well, we already know the answer to this is 4. This is the same integral from above. Then what happens if we use this average value, which says we're going to have 1 over b minus a times the integral from a to b f of x dx? Well, we know that our 1 over b minus a would be 1 over 3 minus 1, and we know that this whole integral here, the integral that we're looking at is the integral from 1 to 3, 9x to the negative 3 dx. Then we know that we're going to have 1/2 multiplied by the integral, which you already found was 4. So 1/2 times 4, we end up with an answer of 2. And this is that f of c value, or what we call the average value for our function. Okay, so that's kind of a quick way, and realize again, this average value is just a way of looking at rearranging that mean value theorem. And again, all we had to do with the mean value theorem is divide by the b minus a. So that gives us the average value of our function. Okay, so again, the mean value theorem is showing us how we can find the rectangle that's going to give us the same area under the rectangle as the same area that's under the curve. And the height of this particular rectangle, our f of c, where this f of c is equal to 2, is the average value.